Today is about properties of logarithm. As you see in the product property, if we have a multiplier, a variable or a constant converts to an addition, and vice versa. If we have a quotient, that will be subtraction. The power property, which is a log base pm to any power, that turns out to be that power times the log itself. Let's say if I have log base 2 of 3x, I could change that to log base 2 3 plus log base 2x. And if you have it as an addition, you can condense it to a multiplier. In the same way, if it's log 3 over x, that translates to log base 2 of 3 minus log base 2 of x. In the power rule, if we have log base 2 x to the 3 or x cubed, that changes to 3 log base 2x. Change of base formula. If we have log base c of some value a, we could change that so it would be easy to calculate or use a calculator for it. Let me show you an example. Let's say if I have log base 3 of 5. Most calculators are not equipped to evaluate logs with different bases. So we could change this to a log base 10 or a common log and want them to be log 5 over log 3. You can also change it to a natural log. And that's exactly what the rule says. In this exercise, we're given values for a log. A log base 7 of 4 equals to 0.712, and a log base 7 of 12 is equal to 1.277. And we are asked to find log base 7 of 3. We are only given log base 7 of 4 and log base 7 of 12. But if I change it to log base 7 12 over 4, that will be the same thing as log base 7 of 3. And then I use the quotient property to change it to log base 7 of 12 minus log base 7 of 4. Log base 7 of 12 is 1.277 minus log base 7 of 4.712. And that would be 0.565. The next one, I need log base 7 of 48. If I multiply 4 by 12, I'll get 48. Do log base 7, 4 times 12. And that's equivalent to 48. And then I use the product rule to change that to log base 7, 4 plus log base 7, 12. 0.712 plus 1.277. That would be 1.989. Problem number 5, I need to find log base 7 of 16. So I'll do log base 7, 4 times 4, and I use the product rule. That'll be 4 plus log base 7, 4. And that's just be 0.712 plus 0.712. That is 1.424. Problem number 6, I have log base 7 of 64. Raise the 4 to 3. So you do log base 7, 4 to the 3. That would be a 64. And now I can use the power rule where I take this, the back there, be log base 7 of 4. So 3, and then the value for log base 7 of 4 is 0.712, and that is 2.136. Problem number 7, log base 7, 1 over 4. Switch that to a subtraction, will be log base 7, 1 minus log base 7 of 4. Log base 7 of 1 is 0 minus 0.712. That's going to give us negative 0.712. Last problem is log base 7, 1/3. That will be log base 7, 4 over 12. The quotient rule on the difference will be log base 7, 4 minus log base 7, 12. And log base 7, 4 is 0.712 minus log base 7, 12, which is 1.277. And that would be negative 0.565. In this exercise, we're supposed to match these logs with their equivalent logs. So the first one, I have log base 3 of 6 minus log base 3 of 2. I could condense that to becomes log base 3 6 over 2 or log base 3 of 3. And it looks like number 9 is here. The next one is 2 log base 3 6, and I can just bring that there. Use the power rule, that would be 6 squared or log base 3 36. And that would match this one here. Number 11, I have 6 log base 3 of 2. I do the same thing. Use the power rule, and that becomes log base 3 2 equivalent to log base 3 64. This one will be here. Base 3 6 plus log base 3 2. So we could convert the addition to a product. So this becomes log base 3 6 times 2, which is 12, which is the last one. Let's move to the next set of problems. Expand the logarithm expression. Problem number 13, log base 3 for x. Well, this is a multiplier, so I'll just change it to an addition. Next one, number 14, is log base 8 3x. That's pretty close to the example I used at the beginning. So it's going to be the same thing, product rule. Number 15, log 10 x to the 5. So this will be twofold, but I cannot apply the power rule first. I have to separate this using the product rule. So this is going to be a log, just log 10 plus log x to the 5, and one more time. So I have to fully expand this. Plus, I use the power rule for this. This will be 5 log x. And I could change this to a numerical value. So this is log base 10 to 10 is 1. Problem number 16, natural log 3x to the 4. So the same way, I cannot use the power rule. I have to use the product rule first, natural log of 3 plus natural log of x to the 4. And now I can use the power rule on that. Number 17, natural log x over 3y. Pay attention because we have to expand these until we can no longer expand it. So I'm going to use the quotient rule. It's going to give me natural log of x minus the natural log 3y. I can use the product rule for that. So I'm going to expand that one more time. And this is going to be a negative. Remember, make sure that you distribute your negative inside this. So it's going to be natural log 3 plus natural log of y. And if you open this up, the final result would be problem number 18, natural log 6x squared over y to the 4th. First, I'm just going to use the quotient rule, and I'm going to break this to. This involves a power rule and a product rule, and this involves the power rule. So now I can continue with my expansion. I'm going to take my first one right here, and I'm going to use the product rule for it. Natural log 6 plus the natural log of x squared minus, I'll go ahead and use the power rule in that one. Then I need to use the power rule for this one, and it's 100% all expanded. Let's do problem number 19 now, which is log base 7 5 square root of x. So first thing I need to change this to a power would be log base 7 5 x to the 1/2. So now I have twofold, a product rule and then a power rule. A product rule first would be log base 7 5 plus log base 7 x to the 1/2. So now I need to use the power rule, log base 7 5 plus 1/2 log base 7 x. That's the final answer. My last problem is 20. It's log base 5, the cubic root of x squared y. So this can be written as log base 5 x squared y to the 1/3. So two ways I can do this. I can use the power rule first, or I could just distribute this inside to the x squared and the y. But it would be a lot easier if I just use the product rule first. So this would be 1/3 log base 5 x squared y. And now I can expand this using the product rule. So it would be 1/3 base 5 x squared plus log base 5y. And I have one more in here. So it's going to be 1/3 the power rule. I'm going to put this here, log base 5x plus log base 5y. Figure out what is the error. So the first problem, log base 2 of 5x, it looks like they multiplied it instead of they added. So it's going to be log base 2 5x should be log base 2 5 plus log base 2x. The next one is the natural log of 8x cubed. So in this problem, it looks like the exponent next to the 8, but actually it belongs to the x, so it should have been here. So this should have been expanded to this. Then the next step, use the power rule to expand it. And that's the correct answer. They're asking us to condense. We'll do as many problems as we can. So we start with number 23. It's log base 4 7 minus log base 4 10. A subtraction, so that changes to a quotient rule. Number 24, the same thing. And you can condense this just to purely this. Number 25, 6 ln x plus 4 ln y. Now remember, you need to put this back using the opposite of the power rule first before you can expand it. Natural log of x to the 6 plus natural log of y to the 4. And now you can use the product rule, and this becomes natural log of x to the 6 times y to the 4. You have to follow these steps, otherwise it's not going to be correct. Problem number 26, 2 log x plus log 11. Remember, again, if we want to condense, we always have to bring the power where it belongs. So this is going to be a log x squared plus log 11, and now we can condense this as a product. Log 11 x squared. Number 27, log base 5 4 plus 1/3 log base 5 x. See the power, we're going to put it back. Log base 5 4 plus log base 5 x to the 1/3, and we use the product rule, and this will becomes log base 5 4 cubic root of x. Number 28, 6 natural log of 2 minus 4 natural log of y. Again, we have to bring the powers, so 2 to the 6 minus natural log y to the 4. We can use the quotient rule for this. That would be natural log of 2 to the 6th over y to the 4th. And 2 to the 6th is just 64, so it's going to be log 64 over y to the 4th. Number 29, but 5 natural log of 2 plus 7 natural log of x plus 4 natural log of y. Put the powers back, so it's going to be natural log 2 to the 5 plus natural log x to the 7 plus the natural log y to the 4th. We need to take any two of these and just use the product rule for them, and then reiterate and use the product rule one more time. So I'll use these two first, then 2 to the 5, which is 32, going to be 32, x to the 4th plus y to the 4th. And I'll do it one more time, and this becomes len 32, x to the 4th, y to the 4th. And I will leave number 30 for you as an exercise to do.